So lesson 3 here, we're going to look at translations of sinusoidal functions today. Translations is sort of a fancy way of saying we're going to start moving things around. So just some quick reminders. Properties, okay, amplitude for sine cosine 1, period is 360. Our normal axis is y equals 0, and our range is -1 to +1, right? Remember, we're starting to write this as interval notation. Okay, don't forget your tables of values, your parent functions, you should know these ones. Okay, a sine table starts at 0, that goes up to 1, back to 0, down to -1, back to 0. And a cos starts at 1, 0, -1, 0, 1. Okay, and we always start with the 0, 90, 180, 270, 360. That part doesn't change. Okay. Our objective today is to start, as I said, moving these things around. Okay. We noticed last lesson we had an A and a K and a C, and that did things to our functions. Well, we're going to add a new letter today, a D. Okay, the letter D right here in the side of the bracket is also going to do some things to us. Okay. In particular, a D is something we call a phase shift. We move it left or right. Okay, be a little careful here though. When you see a minus sign, it actually moves things to the right. It goes the opposite direction as the bracket. So when we get to a positive D over here, it's actually moves things to the left. Because again, if you take out the bracket, it changes signs. Okay. C we already know, we talked about the other day, C is our central axis. It moved our things up and down, and it did just what it looked like. A plus C moved it up, and a minus C moved it down. And we did that the other day when we started talking about transformations. Okay. One more thing, since we don't change the shape of our graph, we're literally just moving it, our period and our amplitude shouldn't change. So those initial properties are still the same properties. Amplitude is still 1, period is still 360. That is not going to change today. So let's look at the first example here. I want to determine the phase shift and vertical shift. Okay, so taking a look at the first one, I'll write them down on the side over here. My vertical shift is my up and down. That's this part right here, +3, outside the bracket. In fact, there is no bracket. Okay, that's my C value, up 3. The part in the bracket, and I said a second ago, there is no bracket right there, is my phase shift. Because there isn't anything there, there is no phase shift. Okay, I'd have to have something inside a bracket to move my thing left to right, and that didn't happen in this case. Okay, our range, we said yesterday, our min and our max can be found by our central axis, our average, plus or minus your amplitude. So our average, our central axis, that's C. Our amplitude, that's right here. We don't see it, so we know it's a 1. Okay. To find our max, we add those things together. That's 4. To find our min, we take our axis and we subtract our amplitude. That's 2. And our y values are always between those two things. And if we have that, we have our properties. Okay, last thing I want to do is I want to sketch this function. Now, you could just move this. This is totally easy to move. The whole thing's going to move up 3. So as long as you knew what it looked like, and you thought about the shape, you can move up 3. Or the other thing we could do is we take our basic table, the 0, 90, 180, 270, 360, and we're talking about sine here, right? That's the question gave us. And a sine curve is those 5 values. And what we want to do is when we move things up and down, is we want to change our y values. We want to add 3 to all those. So our x's would be exactly the same, but our y's were now going to be 3, if we add 3 to 0, and then 4, we add 3 to 1, and then 3 again, and then -1 plus 3 would be 2, and then back to 3. And as I said, the x's would stay the same, so if you want to write those in, you could, or because they're the same, you can just think about those ones. Okay, so 0 and 3, 90, that's right here, right? 90 and 4, 180 and 3, 270 and 2, go there, and 360 and back to 3. So my sine curve, don't stress too much if you don't hit all the dots perfectly, will look like that. The basic sine curve just moved up 3. If you want to try a second one yourself, go ahead, or I'll go through it with you. Okay, so we're still doing our vertical shift. Vertical, that would be my C value, the part after the bracket. Oh, but there's nothing there. Okay, so we'd actually say there is no vertical shift here, right? Let's move that out of the way there. Okay. no vertical shift. It didn't go up or down. It stayed exactly where it was supposed to. Okay. The part inside the bracket is my horizontal, my phase shift. So my phase shift, and remember, it does the opposite of what the bracket says. So I see a minus sign. That means I actually do a plus. Plus means right 45. Okay. And my range, my y values are going to be between, well, my c value was 0. My amplitude is still right here. It's 1. So 0 plus 1 is 1. 0 minus 1 is negative 1. Okay, our standard amplitude, right? Our standard range, which makes sense because we haven't changed that. Okay, a cos graph. Again, if you want to think about the picture, you could do that. Or I like to use these little tables. I think they're really handy, and they get really good at remembering what numbers go in them. So when we do lots of different transformations, it'll make our life a little bit easier. Okay, a cos curve, 1, 0, negative 1, 0, 1. What am I doing to this thing? I'm moving the whole graph to the right 45, which means I have to take my x values and add 45. If you will, I'm really taking this piece right here, right, and do the opposite down there. Okay, so my new x values, x and y, well, 0 plus 45 is 45. 90 plus 45 is 135. 225. 315, and 405. You just add 45 to all the x's. The y's we didn't change. Y stayed exactly the same, so it'll stay exactly the same. And if we graph that one, okay, we have to think about this a little bit. Where's 45? Well, that's 90. 45 would be the halfway point, right? So 45 and 1. 135. Okay, again, that would sort of be the halfway point. You notice there's a pattern here, right? Halfway in one block, there's halfway in the next block. So 135 and 0. Then halfway into the next block would be negative 1. Halfway into the next block would be back to 0. And halfway into the next block would be 405. That's a 1. So my cos curve is still exactly the same shape. It's not longer, taller, wider, anything like that. It's just been moved over. Okay, there's a cos curve. Okay, third one. Give it a try. If you haven't tried the first two, make sure you try this one. Okay, same ideas. Okay, our vertical, ups and downs, outside the bracket. So we're going to say vertical shift down 2. Okay, my left and right inside the bracket. If I do the opposite, it says I add, so I actually have to subtract. So my phase shift, when I'm subtracting the number line, goes to the left. How much? 30 degrees. Okay, my range, my y values. I take my center axis, my C, and I'm going to add my A. Remember, A is 1, hasn't changed. Okay, negative 2 plus 1, oh, still negative 1. That's my max. Negative 2 minus 1, that would be my min. Remember, this is always C plus A and C minus A, right? That doesn't go away. Okay, I got 2 transformations. It's starting to get a little trickier. Here's where those tables come in handy. Okay, make our table. And it doesn't take long to make a table. It takes us, what, 10 seconds. 90, 180, 270, 360. Okay, what kind of curve are we talking about? It's a sine curve. So write down the word sine. Sine starts 0. Okay, what do I have to do? Well, it told me I need to move it down 2, which means take my y's and subtract 2. And my x's, it says add 30, so I do the opposite. Move to the left, I subtract 30. I get a whole brand new table. Okay, what's that going to look like? Well, 0 minus 30 is negative 30. 90 minus 30 is 60. 180 minus 30 is 150. 240 and 330. But I'm changing the y's this time too, right? Take the y's and subtract 2. So I'll get negative 2, negative 1, negative 2, negative 3, and negative 2. And I'm going to graph those. And again, I may have to do a little estimating. Where's negative 30? Well, there's 90. 30 would be a third of the way into that block. So that's negative 60, negative 30, Negative 30 and negative 2 would be about there. Okay, 60 and negative 1, or sorry, 60 and positive 1. I need to find thirds again. So 60 would be there, and negative 1 would be there. 150. So this is 90, 120, 150. 150 and negative 2. Okay, 240. So it's 210, 240. 240 and negative 3. Okay, and this is 270, 300, 330, 330 and negative 2, about there in my graph. Looks like that. Okay, and that takes us to drawing some transformations.